All right, well, thank you guys for making it here. Looking at the snow outside, this is probably one of the nights I'll be staying in, so appreciate you guys coming all the way here. As Chris mentioned, I'm a solution architect at Cohere. For those of you that know what that means, it's basically chatting with our customers. So these could be big organizations, small organizations, organizations of any size, and trying to help them understand how to use generative AI. So Cohere, we play in the very competitive game of language models. If you guys have been keeping your ear close to the news, there's a lot of developments happening this week, past week. Feels like since we started, there's new stuff coming out every week. But it's cool to be part of this space. And we certainly have our little spot where we offer a few different kind of products and options that set ourselves apart. That's what I'm going to be going through in this presentation. So let's kick it off. So how that works? Cool, okay. So this is a little point of view into what we do at Cohere. Let me quickly start off by giving you a very short history of how we started and where we are today. So we started in 2019. Our lead founder, so we have three, co-founders, Aiden, Ivan, and Nick. Aiden was actually on the initial paper that kind of started this crazy generative AI journey. It was called Attention is All You Need. That happened all the way in 2017. Aiden, obviously, a bunch of the researchers on that paper branched off and started their own companies. Aiden came back to Toronto and started Cohere. So what do? As of today, we're about 400 employees deep, which is pretty big for a startup, but it's a good size for us. And we have 4 offices. So we're based out of Toronto, that's where our headquarters are. But we're also in San Francisco, New York, and also London. All right, so what are we known for? Fundamentally, we're known for 4 things. So in this very competitive generative AI space, we're known for enterprise RAG. And I highlighted the enterprise there because we serve the end customer that is part of an organization. So we don't have like a $20 subscription to a ChatGPT. That's not the game we play in. Essentially what we want to do is help big and small organizations and enterprise try and figure out how they can use generative AI to make their workflows better, to drive up efficiency. Any sort of value metric that they want to hit, we try and explain to them how we can do that through generative AI. We're also known for our deployments. So a lot of the times when we talk with different types of customers, let's say we talk to a bank, they're not very comfortable sending data to an open endpoint just for the sake of accessing generative AI services. So we have deployments that serve them on-prem or through secure means, like something like a VPC through cloud. So that's the other thing we're kind of known for. Now, branching off from deployment, we're also known for customization. So large language models today, so if you've worked with the Claudes, the ChatGPTs, our model Command, for example, they're very powerful by themselves. But once you start taking them into domain-specific applications, such as healthcare, banking, we start seeing that they need to be a bit more niche and they need to be customized. So we offer those customization services right from fine-tuning all the way down to the deepest levels of customization, which essentially comes down to building a whole new model for a company. That comes with a big price tag, certainly something I can't pay for, but there are organizations that are willing to do that kind of thing, just for the sake of getting customized models. And then finally, multilinguality. If you've heard of our open research project called Aya, these are models that support a wide variety of languages. Right now we're at about 23, and we're looking to expand that to a lot more. So broadly speaking, those are the 4 things that we try to set ourselves apart on. Fundamentally, the 3 products we have today that we've had so far, because we're a language company, are Chat, Embed, and Re-rank. So Chat is that very familiar ChatGPT type model. Our model is called Command, and we have it in 3 flavors. So we have Command R7B. This is the smallest model. It's our latest release. It's a very light and fast model that can do very complex tasks like summarization and some reasoning. We also have our frontier models, Command R and R+. Hopefully that didn't break. So these models are what you would throw at reasoning tasks, things that are more complex and that you'd want the bigger large language models to handle. On the search side, because again, we focus on enterprise RAG, to bring documents to you, to bring your context, your data to these models, we have Embed, which is an embedding model, and then we have Re-rank, which kind of sets ourselves apart because we're one of the few companies that actually focus on state-of-the-art Re-rank models. So Re-rank helps you essentially rank your search so that it is very precise, whereas Embed helps you drive things up like recall, so it'll get me the most amount of documents based on my search query. So broadly speaking, that's what we've done so far. Now something that's come up very recently is this whole idea of how do you apply generative AI in the enterprise. And sometimes, you know, as a company, we continuously build and improve these models. That might not just be enough. Some customers may want fully fledged end-to-end applications that leverage these models so that they have to put in the least amount of effort to bring generative AI to their enterprise. So while we're in the midst of this very, very, very fast-paced technological revolution, we started in 2017. Again, that's when that attention is all you need paper started. We're at today at this point. So 2025, things are still progressively, kind of changing. There's new models being dropped every week. You guys have probably heard of DeepSeek. You've heard of O1. You've heard of O3. People are branching into reasoning models. We're getting new architectures for large language models like Titans. There's a lot of things happening. And fundamentally, this new sort of frontier at 2030, we believe that when there's mass adoption of generative AI, there has to be a responsible adoption, but also effective adoption. So global businesses have invested a lot of money so far, and we believe that they'll continue to invest a lot more. That being said, we realize today that a lot of businesses have adopted AI, but these are simple POCs, and the push to get AI to production is much harder. So why is that? A lot of the times it comes with inaccuracy. So we've used Copilot, we've built our own RAG applications. I'm sure everyone here has tried that at some point. And then you'll very quickly realize that once you start scaling the application to maybe 2 users, 3 users, 4 users, or you start scaling the documents that it has access to, the harder it becomes for you to build applications that are production ready. These generative models are great by themselves, but they need to be augmented with good search and also good reasoning capabilities to get the right answer out in front of you. Otherwise, they just end up being simple POCs that get thrown in the gutter and not used. So how do we tackle that kind of thing? There's also the second thing over here, and maybe some of you guys fall into this. Over 1/3, about 38% of employees across a bunch of companies that were surveyed acknowledge that they use AI tools with different models and potentially share sensitive information. Hands up if you guys also do that. Okay, good. We're not going to tell on you, but this will also be important. But this actually happens. And a lot of the times for an organization like a bank or a very sort of stringent healthcare association, they can't do this. They need their models on-prem so that none of the data goes outsourced to an API, to a different server, that sort of thing. So we have these two problems. Fundamentally, RAG applications and agentic workflows do not always scale in production. And the other point here is that maybe models need to be hosted on-prem so that the data security and data privacy is resident within your organizations as opposed to sending it outside. So to tackle this, we combined our models and started offering a product at the application layer. So we have Command, we have embedded re-rank in isolation as individual models, but now we also have something called North. So North is our newest product. It combines the best of what we know about RAG and the best of what we know about how to use our models in RAG applications. So North is fundamentally broken down into two things. Part of it is something called Compass. So Compass, think of that as your end-to-end turnkey search retrieval stack. So let's say your organization has a bunch of documents. You might have PDFs, PowerPoints, Excel, CSV, and you don't want to go through the effort of having to parse them, throw them into a vector database, re-rank them, and then get them ready for RAG applications. Compass is your one-stop shop. That's how we developed it. We understand how embedded re-rank works. We understand how to parse these different document types separately. And using that knowledge, we built a tool that lets you connect to your data sets and essentially bring the documents to the generative models. Within North, Command is what powers the generative side. And there's a bunch of other capabilities that we've incorporated, such as tool definitions, connectivity to RBAC for document level access. There's a bunch of things that we've incorporated into North that help make it more appealing for an organization, because now you don't have to go through a new POC every time you want a RAG application. You can ingest, you can set up Compass in your platform and then just set up an agent very quickly. And there's a short demo at the end to show you how that's kind of done. I think that's where we're going. All right, so let me play this. And I'm horrible at playing videos on the deck, so bear with me. Okay, cool. So I'm going to try pausing it. If it's 720p, I know that, so it's going to be hard to see. But I'll try and explain what happens. So basically, we have North, which is an interface, and what you are able to do as an end customer of North is set up your own assistant. So let's say today I'm someone in the finance department, I'm an accountant, and I need some level of RAG capability to do my day-to-day work. So I set up a financial analyst assistant. I connect it to a bunch of data sets that I have access to, and I also give it connection to a bunch of tools. Let's say these are ways to calculate my metrics, something like that. So once I've selected this financial assistant, I can access it through a typical chat interface. I ask it a question. The assistant actually tells me what exactly it's going to do. So based on what question I gave it, it's going to lay out a very small tool plan. It's going to show me what documents it's hit to retrieve the information. And then based on that information, it's going to give me an answer to my question. Cohere models cite things natively. So if I'm using data, when you get an answer, you also see citations for where that data came from. So you have traceability back to source. All right, so I can also ask follow-up questions. So let's say I've connected it to a Python tool. The Python tool can interpret my human language query and turn it into code that will be executed. And in this case, I'm asking it to produce a donut chart. So I send that in, and it generates a chart for me. And we've just kind of showed you what it connects to on the side. So in this case, it's connected to Google Drive, Outlook, and Files. But there's other connectors that we're building progressively as we introduce this to more and more customers. So North at the moment is in early access. We're kind of deploying it at different customers. The latest big news that we had since the start of this year was RBC. So we're working hand in hand with RBC to build North across their enterprise. And we want to ramp it up so that we can scale it to many users within RBC so that they have access to the technology. And we'll soon be rolling it out to different customers. But the hope is obviously that North will be GA towards maybe Q2, Q3, so that we can have it available to the broader kind of spectrum of organizations. All right, so that's where we stand today. We'll let this play for a bit. Thank you for listening to my chat.
Thank you for coming, guys. I'm going to start this off by thanking Cohere for this wonderful space and the team at TechTank for getting this together. I'm Tony Ko. I'm a senior software engineer at Vidal. Vidal is a GCP consultancy. So it's one of the biggest in Canada. It's currently acquired by TELUS, actually. We're part of TELUS, right? Yeah, I joined recently. So, but yeah, I have 8 years of experience in the field. Worked with a ton of different clients, a ton of different corporate projects as well. So being part of consultancies, I got the chance to work with companies like Air Canada, Aeroplan, Air Miles, that kind of thing. We partnered with companies like Vercel and Contentful to help these companies build the products, right? So those are very interesting kind of technologies. Some of the roles I've been in, software engineering, right, obviously, but also solution architecting, engineering direction, hiring, coaching, mentorship, UI design a little bit on the side. It's a little bit of my hobby. So if you want to chat afterwards, come maybe then. So yeah, let's get started. So we're going to be talking about cross-browser extensions, mostly at a high level, right? It's quite a lot. It seems like very little, but we've all used extensions before, right? But it comes with very unique challenges. There's a lot of different edge cases to handle, right? But today we're not going to get too much into the code. We're just going to talk about concepts, challenges, and best practices. So we're going to start with code-based design, a little bit of the data flow, compatibility between browsers, and some UI considerations. All right. What is code-based design? We're going to look at the browser targets, the file structure a little bit, user views of the extension, and some of the tooling involved. Okay, so these are the 4 major browsers. Between them, there's actually only 3 engines, right? Chromium, WebKit, Gecko. I think Chromium is, yeah, they have their own API because Chrome is owned by Google and they took over. But they also have their own extension stores as well. So while you might be able to write code that targets 3 APIs, you also have to think about what these stores support. Okay, so let's break down the browser extension a little bit. Essentially, it's just a zip file that contains a manifest JSON, which is the it defines what this extension can do, like the permissions and things like that. It also defines what kind of pages this extension has. So on the very left, you have the background, which is like sort of the broker, the data broker between all these different pages. You have the pop-up, which is something that when you press the icon, it will have that little, the options page, self-explanatory. There's an example page over there. That you don't really need to have. You can have a lot of different pages in your extension that are outside of these background pop-up and options. And then the last one is the content script. And the content script is it's very interesting because, like you see here behind, I put HTML for most of the pages. That means you can actually open this page. But for content.js, it's actually injected into the page that the user is currently in. Actually, it's injected in every single page, right? So, let's maximize this. Let's move forward. So let's look at it in practice. This pop-up comes from that little icon up there. You press it, and then this window comes up. You can think of it as like a separate page that the browser sort of serves up. It's not a tab, it's just in a little window. And same thing with every single page that's inside the extension. Example option page, pretty straightforward. This one is the interesting one. So it looks like the pop-up, but it's actually injected in the page. So this is actually a React app that, like for example, you get your script injected, and then you can tell the script to create a div and then render your React app in it, right? So this is what's happening here. We rendered it into a fixed div, fixed position div. And because you can inject things into a page, you can inject them onto any vendor's content. Like this is Google, but they injected up here because they were able to detect that this is a vendor that they wanted to advertise, right? And then lastly, the background page, the one that serves as the data broker between all of them, they are actually a page as well. When you go into the extension settings, you can click this, and then a new page will actually pop up, and then you can inspect that page, right? So that page actually serves, like, it runs the JavaScript. Now, you have like 5, 6 different pages, right? What are you gonna do? How are you gonna build these? It's very painful. A lot of people might reach for some tool that they know, like Rollup or something like that, or like Webpack. I would say don't reinvent the wheel. There's actually a framework out there called Plasmo. So Plasmo is kind of like the Next.js for browser extensions. So Next.js is like an application that helps you build React applications, helps you deal with routing, has a bunch of like useful utilities, right? So we're going to use Plasmo to sort of build these things. And what Plasmo is good for is that it has browser-specific logic as well. So you can have like a application, like a script, but you append like app.firefox.js, and only Firefox will run that. And that's really useful because of the API differences between the apps. Also comes with great defaults, some common utils, great community support, supports not only React, and so on. Next one up is Turbo Repo. So you would think that Chrome extension is only front end, right? There's not much point to have a back end. Why would I roll out my own API? But because the way browser extensions work, you might have many instances of this front end and many different versions of this front end. You can't really control when the user is updating their app, their extension. So you need some sort of backend that you can control the versioning of. You need a backend that you can control the caching of. So I would suggest having a separate backend for this. And the way to, for me at least, the best way to manage these kind of backend plus front end repo is using Turbo Repo, right? Turbo Repo, one of the best commands you can use is called Turbo Repo prune. So you can take your extension, the Chrome extension that you have, and only export that extension part out. And that's useful when you need to publish to an extension store, because I'm not gonna put my whole repo up and send even my backend up to Firefox store, right? All right, so to recap a little bit, this is sort of like the ideal view of like the monorepo at the very top. You see the front end, we're using Cosmo. On the left is an example Express app, right? And then a little bit of shared utilities between them. And on your back end, it's not in this picture, but you want to do versioning on your API. So like v2/users or v3/users, things like that. All right, that was a little bit intense. We're going to move on to data flow. So now we have this app. How do we send data between them, right? How do we get data from the backend that we have? There are some concerns about that. So I'll move forward. On the left here, we have an options page, a content page, and a pop-up page. So imagine a content page, you have a React app, it's rendered in somebody's website like Google, right? And then I need to get something from my server. So let's say I want to add an image to Google's website, right? Why not just request directly? Well, usually there's something called CORS, like it prevents prevents a website like Google to request a resource from another domain. So like something like my own API, right? Or even an image. It will prevent that request from happening. In addition, a lot of pages they're designed to only run their own logic. They tell the developers to develop this product and they test against their own functionality. So when you start injecting requests into that page, what's going to happen? You might encounter blocking issues with the main thread, right? And it sounds like something that never happens, but I'm sure you guys all been to pages that are really overloaded already, really slow on its own. And then what happens when you try to post some more requests, put some more logic in there, right? So this is where the background script comes in, the middle thing. Okay, so we're going to use the background script. Sounds good, right? But now we have this problem, and I'm pretty sure you've all seen this before. Some of you guys are guilty of this. But yeah, a lot of tabs are open. What happens there? So you have a content script that's running on all these tabs, right? And you want to grab the user info for your application on all of them. What's going to happen? So let's say you have 20 tabs, 20 requests each. You're not caching them, you're running them nonstop. God knows how Chrome is managing the memories. Maybe some of them are in memory in sleep mode. Maybe some of them aren't. Maybe they're refreshing every now and then. Suddenly you have something that's like calling your API normally once, now it's calling it 30 times, right? And for the extension that we were looking at earlier, the Aeroplan extension, we're talking about thousands of users, thousands of millions of users, and times that by 20, times that by 30, I don't know how many, right? Some people you have 50 times. So we use something called React Query. So React Query is a sort of fetching library in React. But the great thing about React Query is that you can share a cache between them, right? So when I run a query, it will fetch, it will try to fetch. But if there's already something fetching, another instance of React Query fetching, it will be like, hey, it's loading. I'm not fetching yet, right? It's being queued up. And so we have this cache, but how do we share it between each tab? We have to use this extension storage API. So it's an adapter that you can use for the cache for React Query so that they all use the same exact cache, all use the same exact state. So when you, on the first tab there, make a request, the other ones will pause, will wait. So over on this page is a little bit of my strategy of how I tackle expensive requests, right? So first off, I reduce the amount of calls. I use something like React Query. I try to reduce the payload size as well. I mean, it seems like minimum, but when you're that many tabs open, that many users, every little bit counts towards the latency. To note is the CDN. So a lot of people don't really think about that, but let's just say my backend is something like, it has to pull a list of retailers, right? 20 retailers, all the attributes for a retailer. That my SQL call or whatever database call must be big because you might have to like pull all that data. You might have to filter some of them out. You might have to paginate, right? And some of those things you can actually offload to a CDN. You can turn that into a JSON file whenever you update that list, push it up onto the CDN using like a webhook or something like that. And that also will save you a ton of like compute resources. And then lastly is when you horizontally and vertically scale. That's like maxing out the amount of VMs and increasing their performance. So yeah, just a little bit of recap. We're using React Query here to sort of like reduce the amount of calls. We're using the background page as sort of intermediary because we want to avoid the cores issue, right? So all of the requests from React Query is being sent to the background page before being sent to the backend. And then we're also using shared cache. We're using extension storage and then the CDN to maximize the amount of, or minimize the amount of backend hits. All right. Yeah. All right, compatibility is the next one. So there's a little known war happening in Chrome extensions that, yeah, nobody really knows about this except for people who work with Chrome extensions. We all know that Chrome is like the leader in basically browser market share, right? So they're able to sort of control what people use, what kind of technology, how the path of technology that it goes, right? And that's what they've done. So there hasn't really been a standard body to control how browser extensions work. A lot of these things are sort of pushed out by either Chrome or Mozilla, the organization. And Manifest, the file being the one that controls all the permissions, all the permissions and pages for the browser extension. There has been a new version called version 3. It's not exactly new. It's kind of been around for like 2-3 years now. But with version 3, that was a major initiative from Chrome to roll out some new APIs, right? So this web request API here, and this has been replaced by declarative net request. Doesn't sound like much, but web request API is what your ad blockers use to block all your ads, right? It's sort of like a proxy where the extension can sort of read all the data that's being passed through and tell which one that you need to block. This new one is more like a config. You know, you can tell, hey, we're going to block this one, but we can't actually read the data anymore. So arguably speaking, maybe this new API is better, but like from a security kind of point of view, but there's questions being asked because, you know, Google makes, was it $100-something billion of revenue every year, right? And why are they doing this? It doesn't seem like there's much reasoning outside of maybe security. Another big change is background script versus service worker. Background script used to run 24/7, like as long as your Chrome browser is open, it will run. Service workers are intermittent, right? So I guess that makes sense. It's more of a performance enhancement. However, these two things, Firefox, Mozilla doesn't really like, and they have withheld updating to supporting version 3 for the last, I don't know, 2 years, 3 years. It's only recently they started supporting version 3. And then on the Chrome side, Chrome has been deprecating version 2. I think starting 2 years ago, I think this hitting the edge of what's being supported for version 2 now. So you have this little bit of a war going on here. What does this mean for us? uBlock Origin may no longer be supported. So it's kind of like these kind of things you have to watch out for. I think right now the state of it is that Safari has agreed to move forward with Manifest version 3, and Mozilla has started to adapt it, but still with the web request API, they are not kind of, they want to still support that API going forward, Mozilla. And then to add to this war between the two organizations is the fact that they use different name spacing, which is really, really annoying when you try to code. First one, that one's a little bit simple. Chrome extension, the URL, that's like the protocol, and then that was Moz extension. a little bit of scripting will fix that. But then you have something like this, chrome.storage.api. You want to get something from the Chrome, you want to get something from the extension API for storage, you have to use that Chrome namespace, whereas Mozilla uses window. I'm not going to be creating two different files just to do the same thing. My code has to be the same. It has to call one single object. I'm not going to make a separate window.storage. Anyway, and then the last one is Chrome likes to use callbacks, right? I think they started adopting promise-based API recently, but Firefox, Mozilla likes to use promises. So how do we solve this? We use a polyfill called web extension polyfill. It combines the naming structure and also converts the API into a promise-based API, has a little bit of tooling for you to create URLs, so you don't have to worry about that kind of thing anymore. Funny enough, it's actually made by Mozilla. All right, so this part is how to deploy it. We'll breeze through this part. So this is, we're also using Plasma. It offers a GitHub action for you to run. So after you finish developing your extension, you can just use their GitHub action to run it, instead of creating a script for every store and every browser, every file that you have like before. You can use Turbo Repo Prune with this action so that you can export only the Chrome extension part. And then for Safari, there's a special case. Safari extensions, you have to use Xcode. Xcode is sort of a wrapper around the Chrome extension. So Xcode only runs on Mac, right? And you have to use a Mac CI/CD like Circle CI. All right, to recap, manifest version 3 going forward, but watch out for those API differences, especially for blocking. Using Plasma GitHub actions, the prune command to sort of split out your repo, and web extension polyfill to normalize namespaces. All right, this last one's a little bit more interesting, I would say. UI considerations, right? So when you're building Chrome extensions, what do you have to think about? There are some things that I've noticed while building the Aeroplan extension, some patterns that some companies use that I feel like not necessarily are the best, but something that you might want to look at as well. Models. And the last thing is application state. I'll get to that a bit. All right, so here's a video. Before we get started, actually, who here actually likes pop-ups? Raise your hand. There's one person, I think. No, I don't know. Okay, so we're not all crazy. But I'm going to show you this example here. Multiple browser extensions working against each other. All right, so you have some injection there, right? What is happening? So we have this Rakuten extension, and then we also have this United Airlines extension. All right, we're going to go to AliExpress. Whoa, right? That's crazy. So what is happening here is these companies, okay, full transparency, we had a talk with Rakuten. We work with them, but these companies, they are trying to fight for the Z index, basically. They're trying to appear first here. So, particularly the Rakuten extension, what they would do is they would look at what is last on the page, like within the HTML, and usually that last element on that page is the one that can appear on top of everything else, right? But the thing is, there's also a Rakuten Canada extension, and they both have the same logic where they fight for that last position. What they will do is I'm gonna see what's last on the page. Oh, you're last? No, I'm gonna recreate my element on top of yours. And then the other one is I'm gonna recreate my element on top of yours. So we can wait a little bit for that example to come up again. But we have that. And then another thing is that now we have another extension, United. that's not so aggressive, that's just kind of there, you know? And then we have our airplane down here. That's the one we created. So yeah, we have these kind of patterns that you gotta watch out for. I would say, I get it, there's like the difference between like maybe doing the right thing and maybe profits, but there's two ways to play at it, right? You can be better than them, do more of this, or you can just not do this pattern, okay? All right, next part is actually a very similar thing. So, icons in Chrome extensions, you can't actually animate them. So how are they doing this? They're programmatically changing the icon frame by frame every however seconds just to achieve this thing. And I think, like again, it's the fight between doing the right thing and being aggressive. You might get this effect, and it might be great for a while, but how long until they block this API because it's too distracting to the user, right? And then maybe you have a competing product. How many icons will the user be okay with until they're like, yo, what's going on with these browser extensions, right? All right, so fun part's over, but the last part is just something I've been dealing with a little bit. It's a little bit of an annoyance. So we know that this is a pop-up here, and let's say we log in, and we have the React application is tracking the state. Oh, the user's logged in. Let me save the user profile in the state of this thing. And then the user clicks away by accident, and then opens it up again. So what happens? We've lost the state. We've back to this thing, right? Because the React application, they store state internally in the browser memory, but when you close the window, that memory gets erased. So this is one of those patterns where you really have to look out for. You have to use the extension storage API to store everything. It's not just like before when you create a web page, you can store everything in use state. With Chrome extensions, you almost every piece of state that's part of a user flow, you would have to store in the extension storage API. All right, so yeah, some recap. Morality versus profit. App state in storage. All right, finally, that's pretty much it. I hope you guys enjoyed it. If there's any questions or anything, but you can also connect with me here. This is my portfolio. Yeah, I'm gonna hand it over. Oh, yeah.
Any questions for Tony?
Questions?
Hey Tony, I was just wondering, so you mentioned there's the manifest v2, v3, web request API, all those differences. How hard is it to really create a truly cross-platform app? Does Plasmo help you smooth over those differences? Does it do anything for you in that regard? Or do you end up writing a lot of different code?
Yeah, so Plasmo has browser-specific files that you can have. So let's say you have a React app, app.js, you can have an app.firefox.js, right? Or a util that only works in Firefox. So I would say most of the differences you can cover by that. But however, there's two big ones. So the web request one, like hard stop, Chrome doesn't support anymore, right? So if you're creating any sort of extension that filters traffic or looks at traffic, you're gonna have to look somewhere else. And then the other thing is the background script. So in V2, a background script runs indefinitely. In V3, it runs like a service worker. It will die when it's not being called or something like that. And so when you're writing across a platform, you might want to assume that your background script, despite being V2, is gonna die at any moment. So don't store anything in the var. Store it in the extension storage.
Thank you.
Any other questions?
Yeah. When you use React Query, where do you put the query clients? Is it on the page side or is it running on the service worker?
the client's on the page side, but you can pass in storage client, I believe. So that's where the ASIC storage comes in. And then ASIC storage is also layered on top of the extension storage API.
Any other?
Thank you. Yeah, I'm just wondering about how doing the test. So I'm just wondering, how did you do the test about the compatibility between many different browsers?
That's a really good question. I haven't encountered a really solid platform to run tests that allows you to use the Chrome extension API as well. So a few times I would mock those extension utilities, right? Like the storage API, I would have to create like a whole mock around that. Or if you're looking at a bit more higher level, maybe something that automates the browser instead as well. The entire, like more E2E kind of test.
Hello. I actually saw your portfolio right now, and you work at Quantum Mob, which probably is just using the name Quantum, but I am working at the intersection of quantum and right now classical computation. And since you're tackling how cross-browser extensions work, I'm wondering if you have any thoughts around how classical computations and quantum computations could either work, or are there any overlaps in terms of using apps across these different spaces? And if not, what might be the next step in terms of how people could use these current traditional or classical computation resources extended to the quantum space?
I won't be able to answer the question, unfortunately. No, that company I worked for was a consultancy, and they just really like cool names. So.
So I wanted to ask why browser extensions have typically been harder to monetize.
Sorry?
I guess why have browser extensions been harder to monetize?
Harder to monetize. I feel like they're kind of used in a different way, right? Most browser extensions I see are sort of extensions of e-commerce. So for advertising or for an extension for like a web page, right? For something like Pinterest, where they can tap into the user data of a page. So I feel like it's a different way of monetizing it. Not so much. I wouldn't say like the user spends most of the time on the flow of an extension, whereas like if you're creating an application, a web app, mobile app, you're spending your focus on that app, right? So maybe that's another reason why the monetization is a little bit. Anyone else? One over there.
So when extensions actually started, browsers had the dominant market share, and now most of the people are using phones to actually browse the internet. So extensions are kind of like a power user thing. So how do you, and also V3 also reduces the kind of like the superpowers that extensions have. So what's your thought on the future? Do you think extensions are still going to grow, or will they be like, and websites are becoming powerful themselves, so do you think they will like die as for it?
Yeah, that's great. It's definitely not something that's going to be as popular as an app, right? Because the app, you have a lot of push towards it. You have a lot of push from users to install the app and things like that. However, to note, extensions actually work on mobile as well. Like not across the board, but if you think about those web pages that we talked about, like the content script, that is compatible with like a mobile browser as well. And then you have something like the pop-up, right? So usually you have to press a low button and that thing comes up. On some mobile extensions, you have extensions as well. It just takes up your entire screen instead, right? So there are some sort of compatibility with mobile still, but I would say it's definitely not as advertised and not as popular as a mobile app would be.
Hi, thank you, Tony. I just had a question about approvals from the browsers. Like, could you just quickly describe what the approval process is like and how you can get one of your extensions on one of these browsers?
Yep. The most difficult one is Apple's. Actually no, Firefox and Apple. Chrome is not so hard. Chrome is, okay, I'll get into the differences a little bit. So Firefox, you have to submit your source code as well. You're not only submitting the transpiled bundle, you have to give another bundle that's source code. However, Firefox doesn't actually check that source code all that much. You know, a lot of times you go on the Firefox page, it just says, oh, this browser extension has not been verified by Mozilla. So relatively simple actually still. However, I think Apple is the one that actually checks it. So when you submit your bundle to Apple, it takes a lot longer, sometimes like 2 weeks for them to approve. And because of that, yeah, you can't roll out changes as fast. If you have breaking stuff, you have to test a lot more before you roll out because it'll take 2 weeks for your extension to be approved. The other two stores, Edge and Chrome, they're pretty normal, nothing crazy about them.
Just like to top up on that question, how does the resubmission process looks like? So there is first time submission, which of course takes a lot of time. How does the resubmission looks across these platforms?
Right, so on the store, when you submit something, they'll have a status on whether it's approved or not, right? So when it's not approved, just submit again. Yeah, I haven't really had a scenario where they would just spam me outright because I keep submitting bad stuff, so just resubmit. All right, I think that's everyone.
I think so. Oh, wait.
Hi, thank you for your talk. Have you had experience with building extensions or overall the state of extensions, browser extensions in VR headsets?
What was the last part? In
VR, virtual reality headsets.
VR. Oh, browser extensions in VR. I haven't seen them supporting extensions actually, but that is actually really interesting. I imagine those views might be in different places. You know, the pop-ups and stuff. Yeah. You don't have to block the screen anymore, right? But really cool if that actually exists.
Is that every all the questions? And thank you so much for